All right, this is the oldest, most classic example of exponential growth that there is right here. It's the question, if I put 1 penny on the first square of a chessboard, how many pennies would I have back here in the corner on the 64th one? Well, you can see it grows really super fast. That's 64 pennies stacked on top of each other. So I got 1, 2, 4, 8, 16, 32, 64. And I'm videotaping this really quick because the 64 pennies fell down once. So there they are. And I didn't even imagine putting the 128 of them in that far corner over there. So now we're going to talk about the equation and then the math of this. This is the most basic equation that there is for exponential growth. Y is equal to AB to the x. So in our problem here, we start off with 1 penny. So A is your starting amount, 0.01. I'm going to do this in dollars instead of in pennies because it'll make the number a little bit smaller. The number of dollars versus the number of pennies. Now, my growth rate is B. When B is greater than 1, we call it exponential growth, that the curve is going to get larger. So it's B. If B was equal to 1.03, that would be 3% more. If I want it to be 100% more, which is what's happening in this problem, I'm doubling. So B would be equal to 2. So this is 3% more. B of 2 would be 100% more. So B is 2. Now, I want my first penny to have, my first square to have 1 penny. So I need this to be an exponent of 0. So I'm going to do x minus 1. That'd be the number of changes. And that's equal to y, the output. So here's my equation. So if I put in 1 square, 1 minus 1 is 0. And then 2 to the 0 power is 1, and I get 1 penny. So the first square would be 1 penny. Now let's go ahead and put this on the calculator. So if we go 1 penny, 0.01, times 2, then that would be 2 pennies on the next square. And then we do times 2, would be 4 pennies, 8 pennies, 16 pennies, 32 pennies, 64 pennies, and then that's the 8th one. So on the 8th square, it would be $1.28. So $1.28, no big deal. I can hardly buy a pack of gum for $1.28. So here how it would look in the equation. 0.01 times B, which is 2, to the power, the 8th square would be 8 minus 1. So that's the $1.28. So you keep going here, times 2. So that would be the 9th. And we just keep going, and we keep going, and we keep going. Okay, well, now I'm starting to talk about some real money here. And we keep going, we keep going, we keep going. Wow, this is getting really large. So this is just, into the number of squares. We keep doubling, we keep doubling, keep doubling, keep doubling, keep doubling. Let's go halfway across the board. So halfway across the board will be 32 squares in. So 1 penny times 2 to the power of 32 in minus 1. So what are we up to halfway through? We need some commas in here. So there's 1 comma there and 1 comma there. So is that $21 million? $21 million on the 32nd square. Wow, that's crazy. That's only halfway through the board and we're up to $21 million. So comma there, yep, $21,474,832.48. That's how much money there'd be halfway through the board. Okay, so now let's go 3/4 of the way through the board. So that'd be another 16. So 16, 48, 64, correct? So we have 1 penny, and we're going to double, and then we're going to do to the power of 48 minus 1. So that would be on the 48th square. Whoa! So that's to the 12th power. 12th power, that's scientific notation, would be times 10 to the 12. So it's 1.4 times 10 to the 12. So to the 9th power is billions. So that would be trillions. So that's a trillion, trillion dollars, 407 billion dollars. That's how much money is on the chessboard. So now we keep going all the way to 64 and change this to 64 minus 1. And that's how much money. There's 16th power. So after trillions comes quadrillions, and then quintillions, so like 9 quintillion, I believe. That's what that number is. When the numbers get so large, it's hard to even know what they are. But that's how many pennies there'd be. And I'm not stacking anything that tall. I had trouble stacking 64 pennies. Can you imagine stacking 9 quintillion pennies on top of each other? I wonder how many feet that would be, how many miles that would be of pennies. So here's a real world example of exponential growth. In 1990, my mom paid $86,000 for her house. She sold it in 2005. So it was before the bubble hit with the whole real estate market. So it gained 3% a year. So that was the national average, and her house gained 3% a year over that time period. So how much did she sell her house for? So this is an exponential growth problem. It's 3% more, 3% more, 3% more on each year. So I'm going to have my equation here. There's my starting amount, 86,000. And I already established that 1.03 is 3% more. So there's 3 pennies are being added to the dollar. So it's 1.03. And she had the house for 15 years before she sold it. So it's 15. I don't have to do the minus 1, because if I put a 0 here, that represents 1990. So that would be x is equal to 0, represents 1990. So if I put a 0 there, that to the 0 power is 1, and you get the initial starting amount of $86,000. So how much did she sell her house for? Her house did grow at this rate, and this is exactly what she sold it for. So $86,000 times 1.03 to the power of 15. So it went up 3% a year on average for 15 years. So she sold the house for $134,000, and that's right on the money there. During that time period, things did grow exponentially in the real estate market. So that's one of the reasons why during that time period, banks got really creative, and they were giving out all kinds of loans during that time to compensate for this growth. And so they had to be very creative in how they gave their loans, who they gave their loans to make up for these prices going up and up and up, because people's wages necessarily weren't going up that fast during that time period. And then, you know, during later after that, everybody was like, I can't pay this anymore. I made a mistake. So that was part of the it's more complicated than that, but that's part of the reason that we had this big blow up in the real estate and the financial crisis in 2008. So in summary, exponential growth, you have a starting amount, and you change, and if b is greater than 1, it's growth, and it just grows super fast. So it doesn't seem like much, right? Like with the pennies, it didn't seem like very much. Like the pennies were just barely growing, then all of a sudden it just woof, went up really super fast. And during this time period, you're like, I'm bored, I don't have any pennies, right? And even 3% more on a house, if 3% more, well, that's not that big a deal. But then it just starts to go up and up and up a lot. So if we do $86,000 here, we multiply it by 1.03, we have 88,580. I was like, oh, okay, that's okay. Multiply by 1.03, and now we're to 91,000, and then it's just like all of a sudden, you know, you're a few years later, and it's just over 100,000. It's going up and up and up. And again, this was an average rate of change over this time period. So it did grow. That house in the Tri-Cities, Washington, grew at that rate over the time. And there it is. There's the 15 years.